All right, so again, we're starting on chapter 2 notes. This is the graphs of functions. We have two goals for today: identify the graph of a function, and then obtain the information from or about the graph of a function. Okay, and this is going to lead us right into 2.3. We've talked a little bit about this stuff with that little quiz that we saw the other day. When we're looking at graphs, Dom always says every x can have what? What does Dom say about that? Every person can only have Yeah, so every person can only have one birthday. That dirty dog Dom, he had 2 birthdays. Every x can only have one y. Well, to test this, we use what was called the vertical line test. Okay, when we draw a vertical line, that's an x equals line. Right? So vertical, U, V, W, X, Y, Z, U, undefined slope, vertical is an x equals. So I see it only intersects in one spot. I draw a vertical line, intersects the graph in one spot. So every x only has one y for each x that I'm drawing. Okay, this is an example of a function. Every x has one y, but if I take a look, now we have an oval. If I draw a vertical line, let's say I have x equals 5, I'm just making that up. Well, now I see it has 2 coordinate points on that line. So for example, that could be 5, 4 and 5, -4. That 5 is going to 2 different values in the range. We're looking at our Easter eggs. So this is not a function. Okay, so you see the difference between these guys. One's a function, one's not. So the first thing they're going to ask you is determine if the graph is a function. So this is a yes or no question. If yes, then we have to come up with the domain and range. Remember, domain are the x's and range is the y's. Okay? If we think it's not a function, we say no and we move on. So let's take a look. Number 1, function, not a function. What do you guys say? The faster you answer, the faster we can move on, y'all. Function, not a function. Yes or not a function. So, boom, no. Perfect. Next, number 2, function, not a function. Does it pass the vertical line test? Function. That's a yes. Now, if it's yes, I have to come up with the domain and range. D for domain. Okay. That's the x values. So start left to right. What x values do you start seeing? Well, it starts right here. What's this x value? What is that, 0? That's a solid point, so it's inclusive on 0. Okay? And then it keeps going. It keeps going to the right, keeps going, never stops, doesn't stop, stops right there. What's that x value? Is it 10? You guys see that all right? It's inclusive, it's part of the graph, so it's 0 to 10. Okay? If this was like a number line, you know, I would have a bracket on 0 and I would shade all the way to 10 for my domain. So domain is the x values that are being used. Every x value between 0 and 10 is being used. Okay? So again, you should know domain, we work left to right. Range is my y values. Well, domain is left to right, low to high. Range is low to high, so it goes up. So I go up for range. Okay, so I start at the lowest y value. So I don't see anything, I don't see anything. Ooh, I see something right there. That y value is -3. If this was an open dot, I'd use parentheses, but it's a closed dot. It's part of the graph, so I have a bracket. And then how high does it go? Does it go up high all the way to the sky? No, it stops right here at 3. And it is part of the graph, so it's a bracket. All right, questions for domain and range. I think this is called interval notation. Interval notation is probably what my math lab is wanting. I'm almost positive, 99.9%. Any questions with the domain and range? Domain is the x values, range is the y. So if I was actually, put this on a value, it starts here and just keeps going up until 3. Okay, so if you're thinking number line, the range's number line goes up and down. Start low and go high. Okay. All right, let's look at the next one. Function, not a function. Function, not a function. What do you guys say? Function, it passes vertical line test. That's just like this one up here. Okay. So that is for sure a function. And then we have to do domain and range. Okay. Now it's hard to tell, but there are arrows that go like this and like that. Okay. So it means it just continues on. So domain, how far left does this thing go? Does it ever stop? Does it ever stop? Just keeps going. So we would say goes to negative infinity. Range, how far right does it go? Just keeps going, goes up to the right, up to the right, up to the right, up to the right. Goes off the paper. It goes to positive infinity. So using interval notation, that would go from negative infinity to infinity. I would be shading this entire x-axis on what is being used. Okay? This is another way to say all real numbers. Okay? Domain and range is a little tricky for people. Does anybody have a question on why the domain is negative infinity to infinity? All right, let's look at range. Low to high. So the first question I have is how low does it go? Does it go down low? Down to the flow? No. This thing keeps on going towards that x-axis and it's staying right at the x-axis. Okay? And eventually we're going to talk about there's a line that your graph gets closer and closer to but never touches or crosses for large values of x. And that's happening at y equals 0. So your graph is getting closer and closer to y equals 0 but never touches it. Do you guys know what that line's called? Starts with an A. Anybody know what that thing's called? Have you seen that before? Asymptote. Have you heard of an asymptote before? People are shaking their head. Never seen one of those. All right. Well, we're going to dive into that, just not right now. So your graph is getting closer and closer to y, but will never touch that line y equals 0. So it's parentheses on 0. And then how high does it go? Does it go up high all the way to the sky? This thing keeps going and going and going. When will it ever stop? Does it stop? Where does it stop, or does it stop? Does it keep going? Got an arrow. Keeps going and going. So what do I put for the final?
Positive infinity.
There we go. Positive infinity or just infinity is fine. Don't do the plus in my math lab. They'll probably mark it wrong because they're stingy. Okay. Any questions on why that's going from 0 to infinity? That's not too bad. Interval notation we've talked about. All right, ladies and gentlemen, let's move on. Now they're going to give you graphs. Okay. And now they're going to start asking you questions about this graph. All right. So this is my graph. domain goes from 0 all the way to 15, and my range goes from -3 all the way to 3. That's the highest y value, lowest y value. And they're asking you questions. The first question is what, or find f of 0. And then we'll find f of 10. So when they say, hey, what's f of 0? Normally it's x there. So they're saying, hey, x is 0, Shaylee. And what they're wanting to try to get you to do is find out what the y value is. So it's like a treasure hunt. You got to find where x is 0. So I'm looking on this thing. Where is 0 for x? 0 for x? No. Oh, right there. There's the treasure. What's in the box? What's the y value? What do we got? Boom. And that's the answer. So f of 0 is -3. They were asking for the y value. All right, let's go on another treasure hunt. They're saying, hey, Aiden, x is 10. Find the treasure. What's in the treasure? So I look. 4, 7. Oh, it's right there. Aiden, what's the y value? Oh, you get nothing in your treasure box. Wah, wah, wah. So f of 10 is 0. So they're giving you the x value. You have to come up with the y value. Find the treasure. Okay. The next one says, is f of 5 positive or negative? So again, treasure hunt. They're saying, hey, x is 5. What's the y value? Positive or negative? On the treasure hunt, 0, 1, 2, 4. I don't see it. Well, if we look, 1, 2, 3, 4, 5. Here's 5. Go to your graph, and then you have to understand if that's positive y value or a negative. And how do you know? This guy right here, is that going to be a positive y or a negative y? This is 5. Why negative? Yeah, so this is below that x-axis, right? If it's below the x-axis, then we know the y values are negative. If it's above the x-axis, then we know the y values are positive. Awesome. You guys are doing great. All right, let's take a look at the next one. It says, for what values of x is f of x greater than 0? So what values of x is f of x, which we know is y, greater than 0? Well, the first thing we got to know is what is the line y equals 0? The line y equals 0 is the x-axis. So if I draw a little dotted line across, that is the line y equals 0. This guy right here. Well, they want to know where are the x values above the x-axis. Where are they greater than? Where are my y values greater than 0? So I look. These are all negative. Negative, negative, negative. 0. Now these are all positive, positive, positive y values. Positive, positive, positive. 0. Negative, 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 0, 0, 0, 0, 0. So my answer is all of these x values between 1 and 4. Okay? Well, is the y value greater than 0? No, it's equal to 0. So we don't include that. It's kind of like there's like an open dot there. So we would say it starts at 1 and it goes all the way to 4. Okay? Now, this is not a coordinate point. This is, again, interval notation. Okay? My math lab's going to be asking you guys for interval notation. And it's just from what x value to what x value do you see it above? Well, it's above between 1 and 4, and that's how you say that mathematically, using interval notation. All right, domain and range we talked about a little bit already. Domain, x values. From what x value to what x value does this thing go? Let's pick on a few people here. All right, Zoe E, David, Dylan, Jesus, Emma Kip. What's the domain? From what x value to what x value? What's the lowest x value? What's the highest x value you guys see? Lowest to highest, y'all. Are we not sure?
It's really blurry for me, but like 0 to 10.
0 to 10? Close. It starts at 0, and I can zoom in a touch more here. Is that better?
No, it didn't really change anything.
Are you guys having trouble seeing this? You got your glasses on. Are your glasses clean? All right, hopefully this is a little clearer. I've got 0, and it goes all the way to 15. Now, don't list. This is what happens. People will list the x values that they see. No, 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 no. Well, every x value is being used between all these points. So you have to include them. That's where we use interval notation. So what is the domain? My domain starts at 0, and it goes all the way to 15. This just means that every x value between 0 and 15 are being used. Okay? And then the range, the lowest y value is -3, and it goes all the way up to 3. That's the highest. So domain is left to right. Range is bottoms up. So it starts at -3, and it goes all the way up to 3. Hopefully that's clear for you, David. All right, last but not least, I got how often does the line y equals 1/2 intersect the graph? Okay, so again, we got to know y equals y, z, 0 slope, horizontal. If I have a horizontal line, it's going at 1/2. So here is 1, here is 0, so it's like right in between it, between 0 and 1. That's what the line y equals 1/2 would look like. Well, it looks like it intersects in 1, 2 spots. 2. So I have it intersecting in 2 spots, 1 and 2. Okay, so this takes care of number 1, identifying the graph of function. Number 2, attain some information from the graph. Okay. We got one more thing we got to do is walk you through some algebra with evaluating a function. Okay. So this could be a graph of a function, and we should be able to answer all of these questions about this graph. Okay. So I got f of x is x squared plus 2 all over x plus 4. First question is 1 comma 3/5 on the graph? Well, this is x, and that's my y. Or this is x, and that's f of x. So all I got to do is I got to plug in 1 and see if I get 3/5. If I get 3/5, then the answer is yes. If I don't, then the answer is no. So all I got to find out, what do I get? So anywhere there's an x, I always like putting parentheses, and then in parentheses, I'm going to plug in 1. We know 1 squared plus 2 is 3. And then 1 plus 4 is 5. And then f of x is 3/5, so we get 3/5 equals 3/5. Check. Yes. Okay. If I don't get 3/5, then the answer is no. Easy peasy. So the next question says, if x equals 0, what's f of x? So they're giving you an x value. They want you to come up with the y value. Okay. So remember, this is like y. So we go ahead and plug it in. Some of you guys can do that really easily. I like the cover-up method, right? 0 squared plus 2 is 2. 0 plus 4 is 4. And we get 1/2. Well, that's the y value, so they want you to come up with a point on the graph. Well, that point, we plugged in 0, and we got 1/2. Now, that is a special point. Does anybody know what that point is? Very special point on the graph. What do you guys know that point is? Anna, Shaylee, Faith, Hunter, Emily, Natalie. What's that point? Very special point in the graph when x is 0. What did you just find? Mm-hmm. You betcha. That's where it touches or crosses the y-axis. Very good. When x is 0. All right. Next one says, if f of x is 1/2, what's x? Well, this is where I take this and I plug it in. So instead of f of x equals, I have 1/2 equals x squared plus 2 over x plus 4. So now we have a proportion. You guys remember how to solve proportions from back in the day? How do we get rid of these fractions like this? Easy thing to do. Yeah, multiply by the reciprocal. You could do that. There's another way to do it too. What's this called? What's this called? Yeah, buddy. So we could cross multiply. You could also multiply by 2 and then multiply by x plus 4, but cross multiply does the same thing, a little quicker. So 1 times x plus 4 is x plus 4. And then 2 times x squared plus 2, we got to distribute. That's 2x squared. 2 times x squared. 2 times 2 is 4. We have a quadratic. We got to know how to solve quadratics. We did this in A6. You subtract that 4 over. We have x equals 2x squared. Again, we always want our stuff equal to 0 if we're going to factor. So I got 0 equals 2x squared minus x. Then we factor. First rule of factoring is we're always looking for what? What are we looking for? Boys, you need to get your Zooms going. Good job, Peyton. Get your Zoom going. First rule of factoring, what do we look for, guys? Starts with the first letter of Mr. Gotch's name. Emily, what do you think? Lindsay, what do we do? What are we looking for? First letter from Mr. Gotch's name starts with what? Yeah, the GCF. When you look for the GCF, in this case, I can take an x out. That leaves me with 2x minus 1. You can set each one of these x's equal to 0. You get x equals 0 for that one. And then for this one, if you need to, set it equal to 0 off to the side. Add 1. 2x equals 1. Divide by 2. And we get 1/2. So we get two answers. When y is 1/2, we got 0, which we had up here already. When y was 1/2, we got 0. But then also there's another x value that has the same y. These two x's have the same birthday. That's okay. That's normal. Domain. We've talked about domain already. Chapter 2:1. Domain, we look at the denominator. Denominator cannot be 0. So again, when we have a function, x squared plus 2 over x plus 4, for my function, domain, denominator, this guy, can't be 0. X plus 4 cannot be 0. You subtract the 4 over, x cannot be -4. If they want the fancy set notation, look like this. And that's good to go. Let me know if I'm going too fast. All right, next, list x-intercepts. You got to know a little bit about x-intercepts. What do you guys know about x-intercepts? Allie, Rachel, Zoe H. What do you guys know about x-intercepts? X-intercepts and y values. What do we know about y values? Awesome, Zoe H. Fantastic. So x-intercepts are when y equals 0. Or remember, that's when f of x equals 0. So we're going to go ahead and plug in 0 right here for f of x. So instead of f of x equals, I got 0 equals x squared plus 2 over x plus 4. Now think of that as that proportion again. When I cross multiply, 0 times anything is 0. And then 1 times x squared plus 2 is x squared plus 2. Now, you could try to factor that. That doesn't factor. You can try subtracting the 2 over. We get -2 equals x squared, and then square root both sides. But what's the square root of -2? Square root of -2, y'all. What happens when you plug that in the calc? What do you get? It's okay to turn your mics off, guys. You know the answer. Cameron, Andrew, David, Dylan, what happens when you square root -2? What's that? It doesn't work. Yeah, you get no real solution. So if you ever get that, well, it just means no x-intercepts. So there is none. Okay, but do what Zoe H said. Hey, I know x-intercepts are when y or f of x equals 0. Plug in 0 and solve it. A little algebra. Last but not least, you got y-intercepts. Same idea. That's when x is 0. Well, we've already done that, right? We did this up here. We don't need to do it again. We did that up here. We found our y-intercept. Plug in 0. Use the cover-up method. Okay, so I'm not going to redo that one. We already did it. We got 0, 1/2.